Hey, what's up everybody? It's Mike from Cornfield Customs, and today I'm going to answer your most commonly asked questions about mandrel bending, tubing, and setup. So stick around as we go through your guys' questions.
How do you know where the mandrel is?
So how we know where the mandrel is there's two different locations. We swing the carriage out of the way to start, and here's the mandrel, and it is in the retracted state right now, so that is at the farthest back of its stroke. So from there, the other setting is fully extended. So what I'm going to do is I'm going to turn the machine on, I'll extend the mandrel forward, and then we will measure it, and we can see where it stands, and I'll talk about how we locate that. I need to come right through there. Now the mandrel is in its fully extended location, and what we have to do is we have to measure from the front of the die to the front of the solid section of the mandrel. And this can vary a little bit depending on which mandrel we're using for which wall thickness. So right now I have the mandrel in here for the 188 wall tubing, so it'll vary from what our 120 wall dimension is. So the 120 wall is 6.875. And with the 188 being a little bit thicker of a wall and it being a 2 detent mandrel versus a 3, which I'll show you later in this video, it's going to vary just a little bit. So I bent some 188 on this yesterday, and we are at 6 5/8. So it's just a little bit different, but that's how we know where the mandrel sits. It's forward or back, and then we can adjust that by loosening these jam nuts in this extension collar, and we can tighten or loosen this to move the mandrel back from its fully extended and retracted phase. So each time we change the tooling or the mandrel, we have to adjust this, calibrate it, and once I get it where it needs to be, or where I think it needs to be, I will do a test bend to a 90, and I'll inspect the tube to see if there's any wrinkling, splitting, deformation, or anything that I don't want to be in there, and I'll adjust the mandrel according and do another test bend. So it's a little bit of a drawn out process in the beginning to get that mandrel set, but that's kind of how we do it. Just adjust this, get the mandrel right at the tangent point, and from there we will get that set in the proper location to get a nice wrinkle-free bend.
What do you use this little piece of metal for?
This piece of metal is my edge guide, so it's kind of hard without having a reference mark. I'll just use this piece of tubing. So we'll just say that there is a reference mark here. This is the 0 face of our tube, or of our die. So when I lay out our yellow mark in some of the other videos, I line this up with the face of the tube, and it lines up with our reference mark. So I just use this as a gauge to get my 0 point to start to bend at comparative to the face of our tool.
Our next question is, what is the heaviest gauge metal you can bend?
So the heaviest gauge metal I can bend on this mandrel bender is 188 wall, and that is maxed out at 2x4. I get a lot of people that want me to bend 2x6, 2x8, or even 2x10, 120 wall or 3/16 wall, and that's a lot of tubing and a lot of material to bend. So I only bend up to 2x4, 188 wall, and anything more than that is going to be really rough on the machine, and it'll probably break it. So that's about my limitations on this machine.
What is the mandrel made of?
So the mandrel is a machined part, and it's made out of aluminum bronze, like a wear plate. Each mandrel is going to be a little bit different. So the 2x4 188 wall mandrel is similar to the 2x3, where it only has 2 pivoting sections of the mandrel, while the 2x4 120 wall has a third that goes beyond the tangent point of the bend, and that's what these little flexible pieces do. The solid point goes right to the tangent point, while the flexible pivoting pieces go beyond the tangent point, but the main material they are made of is aluminum bronze, which is a very durable but wearable part.
Why does it need to flex?
It needs to flex, that way these sections can go beyond the tangent point. So I'll flex that here. So is the tube bends, the tangent point is where the bend is going to start and stop. So this is being supported in the straight section, and then the start of the bend is being supported as the tube is drawn across the mandrel. So it has to flex to go up in past the tangent point of the bend itself.
Oh, okay, that makes sense.
Yep.
So when the mandrel's in the frame and you got to rotate it 180 or so, does it rotate 360 or in the frame, or?
No, the mandrel cannot rotate in the tube at all. So here's our mandrel and here's our tube. You can see that it's a nice snug fit. So there's really no way for that to rotate in there. But what happens is on the far end of our bend bed, that is a pivoting ball socket, and we can rotate the mandrel, this whole extraction bar, and the mandrel. So it rotates as a unit. So when you see me rotate the tube in the machine, this whole bar and that ball socket is rotating at the tail end of the machine.
When you're talking about bending frames, what is easy way and what is hard way?
So the easiest way to remember that is on 2x4, you have a 4-inch leg and you have a 2-inch leg. It's much easier to bend on the 2-inch leg than it is the 4-inch way. So that means bending on the 2-inch is the easy way in bending. And here's a couple examples. So this is 2x3, not 2x4. So this is bent the easy way, where the 2-inch leg is doing the bending. So the inside and outside are not doing the majority of the bending. While here is a section of 2x4 120 wall bent the hard way. So we're bending the 4-inch leg, while the 2-inch inside and outside aren't doing much bending. So hopefully that makes it a little more clear. It's way harder to bend 4 inches of material than it is to bend 2 inches of material.
Do you design the frame rails of the cars?
Some of the frame rails I do design in-house completely from scratch, like the Hanchard Special frame rail. It's based on a Model A, so this is a very simple frame. It's straight and flat all the way until we get to the rear axle kick-up, and all I needed to do was figure out where I wanted the kick-up to start and how high it needed to come up over the axle. A lot of times I get a rough sketch from the client or the end user that just has dimensions and what they need, and I will draw that in CAD and send them a 2D or 3D proof to verify it's what they need. So a lot of the times I'll do the end design work, but I won't do the initial dimension pooling because it's all going to be different, and I do a lot of work for clients all over the country where I don't have access to the vehicle they need. So I start off with a basic sketch, basic measurements, design it in CAD, send it over to be verified, and adjust accordingly. So I do design some rails completely in-house, while others I rely heavily on the end user or the client to provide the dimensions they need bent to.
Have you done any aluminum frame rails?
I haven't done aluminum frame rails because you really don't need an aluminum frame rail. It's not going to be structurally sound unless it's a specific application, which I haven't run across yet. But what I have tried to do is do some aluminum extrusion 2x4 120 wall for a greenhouse for a client, and some other parts that needed to be out of aluminum. The problem I found with the extrusion is it's very inconsistent, and you can go in 6 feet on one part and it kind of necks down and it gets stuck on the mandrel, or it can go in 6 inches. There's just no good way to get that precise of a fit across the mandrel for the extrusion. So I've not had any luck successfully sourcing aluminum material that will work in the bender. I think it'll bend it, but we won't know until I get that material that fits really well over the mandrel.
Do you have to remove the weld seam from the metal?
I don't have to remove the weld seam from the metal. The 120 wall tubing that I buy is a special type of tubing. It's 2x4 120 wall hot roll P&O shave seam. So it's specially made by the mill, and it has very little to no weld seam in here. Hopefully you guys can see that. There's just the way it's made, it has very little weld seam, but depending on the mill it comes from, that can vary. So if you look at the mandrel, I do have grooves cut into the top of the mandrel, which I don't like to do, but when you buy 50 sticks from a mill and it has those grooves in it and you have it freighted in from out of state, I'm kind of stuck with what I've got. So I do have some grooves machined into the mandrel to account for the weld seam. just in case I do get that. So even on the 2x4 120, the 2x3, the weld seam is on the edge instead of the flat 3-inch side. So I had to machine a groove there, and the same on the 188 wall. So ideally I like to have this shave seam tube that comes specially made for bending, but I don't always get that from my supplier. So I don't have a way to cut that weld seam off, but I have a workaround in case it shows up.
How do you measure spring back angle?
So to calculate my spring back when it comes to rectangle tube, especially in this bender that is programmable, when I set up our bend tooling profile in BendTech, what I do is I bend certain pieces of tubing, the corresponding material that we're working with. I'll bend it to 45, 90, 100, just a bunch of random angles, and that'll be programmed just to that number. So say that I need a 90. I'll program 90, I'll bend it, and then I'll measure what the actual achieved angle is. And by doing that over numerous parts, just as tests, it creates a curve that shows, with doing those series of bends, it creates a curve or a chart that calculates the spring back needed to get to our achieved angle versus our desired bend angle. So once we design our part in BendTech, it'll give us the desired angle we want, and it'll calculate how much spring back we need to account for. So then I just program as our spring angle will be 92.3, and that will yield us a 90-degree bend out the door. After the initial test bends to calculate our spring back curve, the software does all the hard work for us, and we just program in what we need.
So why would someone need a custom frame made for their car?
There could be a lot of reasons why people need a custom frame built for their car or trailer or anything else. And a lot of it comes down to changing out the suspension or just having a bad frame to begin with. It could be cracked, rusty, or damaged. So most of the stuff I do is not going to be a stock parameter profile. It's always going to have a different kick up in the front to accommodate a more modern front suspension like a Corvette or a Mustang II, or something the client is designing on their own. As well as in the back, it'll have to be kicked up over the rear suspension to get the car to sit lower. Just like on this car, which is a Model A, the Model A was originally straight all the way across, but to get this to sit a little bit lower and get us some suspension clearance, I added this kick up to come over the top. So those are the two main reasons why you need to have a new frame built. You can modify a stock chassis to suit your needs, but a lot of people are wanting the clean and simple look of a mandrel bent rail, and I find that's why a lot of guys come to me to have rails bent, is it's just faster, easier, and a nicer finish to achieve what they need to get the car to sit how they want.
What are some softwares you use for building frames or other CAD stuff?
So when it comes to doing my frame rail stuff, I use two different types of software. I use 2D AutoCAD, that does the center line and overall main design work, and from there I will export that as a DXF and then re-import it into BendTech, which is a special bending software that works with many different types of tube benders, including the mandrel bender, and I can import that DXF and it will turn it into 3D, and it'll do all the math again and print out a worksheet. This is a very simple worksheet. It is just a straight 90, but I like doing it this way because it gives me a part date, the print date. I can put the name on it, any revisions. It gives me all the material, the die selection, our center line radius, our calculated radius. Gives us our cut length, our part weight if I have the material weight in there, and then all of our bend locations and the degree I need to bend to. So I always finish everything out into BendTech software because it just makes life easy and it makes sure that the frames are spot on every time. Well, all right guys, that wraps up this video of the most commonly asked questions I get on the mandrel bender and setup. Hopefully that answered a lot of the questions you guys have. If it didn't, drop down in the comments section and ask me the questions and I'll do my best to answer them. If I get enough of them, I will do another video like this one, explaining it more in depth so you guys have a greater understanding of what goes into the design and bending process of custom mandrel bent frame rails and parts. I want to thank you guys so much for checking out this video and the channel. The support I keep getting from you guys is is just amazing. And I feel so fortunate that you guys are supporting me and supporting Dom with checking out the channel, commenting, and just everything you guys do. So thank you guys so much for checking out this video as well as many of the other ones on the channel, and we will catch you guys on the next one.